In the second tutorial from our ibaAnalyzer series, we show how product-related key quality indicators, KPIs, are calculated from machine measurement data. To do this, we convert time-scaled material thickness values into length-based values, determine the tolerance-compliant effective length of the hot strip, and calculate the scrap lengths for head and tail trimming. Finally, we extract the results into a database for further analysis. Let's start by opening a suitable product-based measurement file. In the first example, we have already become familiar with the interface of ibaAnalyzer. After opening the file, we see directly all available signals in the signal tree on the left-hand side. There, in Module 3, we will find a signal for the material thickness, the signal with the number 315. Double-clicking on the signal causes all thickness values to be displayed immediately. But there is one problem. The signal trend also includes a lead and lag time, which is not relevant for our evaluation. That means it is necessary to define the time range where all thickness values are valid. The easiest way to exclude the lead and lag time is to create a new virtual digital signal that describes the valid time range. The signal could be created by right-clicking at the beginning of the signal line. Let's call this signal mat thickness valid. Now you can use a normal logical function. Checking the thickness signal 315 for greater than 0 provides a digital signal that describes this relevant time range sufficiently. For a better visibility, we can move the signal to the upper trend, to the thickness measurement value, and adjust the color. For the conversion to length-based values, ibaAnalyzer provides the time-to-length function. This function needs two arguments, the expression which should be converted, and a suitable speed signal. For both arguments, only the relevant time ranges are required, so the use of the function must be prepared in two steps. In the first step, we cut out the valid thickness values. This requires a new virtual signal again. Let's call it mat thickness relevant. After opening the FX editor, you can search for the xcut valid function, which requires an expression and a validity signal as arguments. For the last argument, you can use the previously generated virtual signal mat thickness valid. In the second step, we do the same with the material speed signal 119. In the final step, we add a new signal again and use the time-to-length function to convert the thickness values to a length base. The result is a new trend of the thickness values with a length-based x-axis. The length-related x-axis now corresponds to our strip length. This can be calculated very quickly using the xsize function. In this case, our hot-rolled strip has a length of 58.1 meters. In the next step, the area of the coil that lies within the customer tolerances must be considered. A logical comparison with the applicable limit values helps us here. Ideally, this value is recorded at runtime and can then be found in the signal list. In this case, we do not have these specifications available in the measurement file. So, we create a new signal for the upper and lower limit values. The upper limit value is 2.325 millimeters. And the lower limit value is 2.25 millimeters. Both signals can be drawn into the upper, length-based trend of the material thickness. In order to assess which length range is within the tolerances, a further logical comparison is necessary. The relevant thickness value must be greater than the lower tolerance value, as well as smaller than the upper one. The usable length range is now known. What is still missing is the exact length and/or the scrap lengths with the cutting positions. The exact length is easy to calculate using the integral function. While the integral of a time-based digital signal returns the runtime, it is the length for length-based digital signals. Only the signal state true is relevant here. Now, only the lengths for the head and tail cuts are missing. These can be calculated very easily using the x-first and x-last functions. The time of the first rising edge or the last falling edge is returned via this function. The rising edge returns the scrap length of the tail cut. If the result of the x-last function is subtracted from the total length of the coil, the scrap length of the head cut is obtained. For better visualization of the cut positions, these can also be created as markers. The configuration dialog can be opened by right-clicking directly in the trend. The functions used would again be x-first and x-last. The created markers are displayed directly in the trend, but are also available for other trends in the signal tree. The calculation of the product-related characteristic values is now complete. The last step is to prepare the extraction into the database. To do this, the database interface must be opened. You will find the icon for this in the toolbar. The database connection must be entered for the first extraction. In our case, we can dispense with this as the connection already exists. When extracting to the database for the first time, the default columns must be created initially. This is triggered via the existing button. The interface has several tabs in which the contents of the database extract can be entered. In our case, only two of these tabs are of interest, the Info Assignments tab and the Calculated Columns tab. Content from the info fields can be entered in the Info Assignments tab. In our case, we find information on production time as well as product-related metadata, such as customer, order number, or material type. The start and stop time can be added simply by double-clicking. If the millisecond information is not required, the relevant information area can also be restricted in the functions. This can be done either via a customized marking or directly in the functional expression. The results of the length calculations can now be entered in the Calculated Columns tab. Please note that only discrete values can be processed here. If signal curves are entered in this tab, ibaAnalyzer will automatically calculate mean values in order to process the result. If the database tables are available, extraction can be carried out. After successful extraction, the data can then also be displayed in the Database Management Console. Numerous further analysis options are of course also available there. This was the second ibaAnalyzer tutorial, and we'll see you again in part 3.